All right, guys, let's do number 33. As soon as the traffic light turns green, a car speeds up from rest to 50 miles per second with a constant acceleration at 9 meters per second. In the adjacent bike lane, a cyclist speeds up from rest to 20 miles per hour with a constant acceleration of that. Each vehicle maintains constant velocity after reaching its cruising. For what time interval is the bike ahead of the car, and by what maximum distance does the bike lead the car? And I did solve this. And see, let me see what I put there. Oh yeah, I didn't put anything on the solution because the units. But anyway, let me set this up and then I'm going to pull this. Alright guys, so here's the equation. The equation is going to be the position, it's going to be the final velocity minus the initial velocity over 2 times the acceleration. In the bicyclist, the initial velocity of the bicyclist, actually let me write these variables down. All right, so the bicyclist is going to have so notice that the bicyclist has more greater acceleration. They're going to go start from the rest, so it'll be not it's just going to be, both of them is going to be 0 meters per second or miles per hour, whatever, and this bike is going to have a bit more acceleration, so it's going to go ahead of the bike, maybe not like that, but something like that. I can't really draw that well. But once it reaches its 20 miles per hour, then this is going to turn into a straight line. And that's the position for x. So from 0 to whatever that time interval the velocity of the bike is 20 meters per second, it's going to be this part. And the blue car is going to get lower, but I'm not sure. I guess I can find the time it takes for both of them to reach their cruising speed. In fact, so the time it takes for the bicyclist to reach its velocity is 1.54 seconds, and it looks like here that the car is going to take a bit longer. So I did do it a little screwed up, but whatever. And, oh, why did I don't know. Let me see if I can redraw this. Something like that. Something like that. It's a little hard to draw this, but it's okay. So at 1.54 seconds, so this is going to be 1.54 seconds. The car is going to, the slope of that straight line is going to be 20 miles per hour. And the car here is going to be 5.56. I know my graphs is never to scale. The slope of this line, which I kind of exaggerated a little bit, is going to be 50 miles per hour. It's going to be more slanted than the other one, so maybe I should draw it a little more, but that's all right. There we go. So I would suspect that this would intersect in the parabola and then the green one, but I'm not certain on that. But it looks something like that. For what time interval is the bicycle ahead of the car? Well, you set up your other motion, or actually, I guess that this would be pretty straightforward to set up for the parabola motion, and then and then here you let be 20 miles per hour minus t times t minus of this time interval to shift the graph towards the right. Use your standard rules of algebra or whatever you learned if you paid attention, and or in this case, anyway, I can't really explain. Here's the solution manual. Anyway, folks, here's the solution manual, and the reason why I'm pulling this up is because I don't want to have to convert from miles to feet or whatever the heck, and that's just I don't want to deal with that. So this is why we like the metric system, guys, because it's so much nicer for us. So anyways,